Hello everyone. I hope everybody's doing fine, better than me. I had a little problem yesterday. Uh, Something happened to my eye. Um, I was just walking down the street and a bug hit me right in the center of the eye. And that left me blind for about a minute until I scraped the bug off of there. And I was working with a cement after that, and a bit of it fell on the ground and just splattered in the same eye. And so if you see me crying or see that my eye is red, then you'll know why. I've just been cleaning my eye out with a little bit of water and salt, and that's cleaned it up a little bit. So just so you know. Anyways, today I want to talk about the neutron. And a good place to start, and the reason for this is, we brought it up at the forum over there at the Facebook forum that we have, Rational Science. And a good place to start is at the beginning, just like the Bible. In the beginning, la 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 la. Okay, so where do we start? Where is the beginning? Well, the beginning is what we covered in the last 2 weeks. Approximately, and that's with the golden principle. The golden principle says that physics requires an object. You can't do physics without an object. I mean, what would there be to study? What would you be observing if there were no objects? Vacuum. And if physics requires an object, the next step is to define what an object is. And we define it in physics as that which has shape. The universal property all objects have is shape. And that's our starting point. That's the beginning. Okay? And so what's by the way, if you can't hear me or if the image comes out wrong, please let me know as soon as possible in the comments section. I'm a little paranoid about that. I've had all kinds of problems in the last couple of weeks about sound especially. So if you can't hear me or my sound comes out wrong for whatever reason, let me know. Anyways, neutron. There's a little preamble I want to say about the neutron, or in general. And that's that, yeah, physics requires an object, and an object is that which has shape. The problem we run into is that in this, at least I would say, at least since the 19th century, and even earlier than that, people have tried to figure out what invisible objects serve as mediators, like for light, for the atom, whatever the atom was, whatever they imagined it to be. Electricity, 19th century, when they found really was with Benjamin Franklin. He already knew a little bit about electricity, and other people as well, Gilbert and so on. They dealt with magnetism and electricity. Volta, 18th century, I think, was a starting point for that. I'm not sure if they knew about electricity before then. And so, you had to figure out what invisible entities are mediating these phenomena. What is magnetism? What is electricity? What is light? What is gravity? All invisible. And so the visible stuff, we had no problem. After a while, we figured it out. But the invisible stuff, how would we handle that? And so one of the problems we have with the neutron is that we're dealing with an invisible entity, an invisible object. That creates somewhat of a problem because different people might come up with different ideas what the neutron might look like. And that was exactly the case in our forum, in our Facebook area, forum, the Rational Science Group. Different people came up with different notions of what they thought the neutron was supposed to look like or be. And they had different justifications for it. And not everybody agreed with me, and I'm hoping that you don't. Because what happens when you have an invisible entity that you will never, never be able to see, right, is that you're going to have to brainstorm. And fortunately, we got the right kind of people to do this. They're not the right people because they're the smartest people in the world or the most intelligent. It's because they have an open mind. They have an open mind, and they're willing to consider different things that nobody else has pondered. They're not distracted by dogma. You go to the university and they teach you something. What do they teach you? They teach you to memorize. You memorize for the test. So you read from pages 40 to 50, write a report or prepare for the test, and then you leave the school and say, thank God I got an A. That's it. It's not like you really have too much time to analyze what you read in any real detail, because you got other courses and you just want to get a degree maybe. It's not so much for understanding, it's for I guess you could call it learning, but not understanding. And that happened to me, by the way. I'm no exception. When I studied, I learned a lot of stuff, and I learned a lot of stuff by rote, in a sense. In other words, it didn't really sink in. It was when I had, a little bit of free time, I sat back and I analyzed some of these things that I came up with, the rote model. And that's when I abandoned mathematical physics, because I realized that mathematical physics has no rational physical interpretations, for any phenomenon in which an invisible entity serves as a mediator. And so now we're at the same place. We've got these people who are willing to think outside the box. They're willing to ponder alternatives for whatever reason. And yes, what's going to happen is that, if all these people get together, they come up with different ideas and say, no, this is not what I think of the neutron as. I think of it this way. And this guy says, no, I think of it that way. And there's a third guy, and he thinks of it in a separate way still. And again, they have different justifications for why they think that way. And this is all good. It's not good because they get black eyes fighting against each other. It's good because we're brainstorming. We're brainstorming, and that's only natural, I think you would think, first because it's an invisible entity, and second because this is a new theory, a new proposal, a new hypothesis, in the case of light and the atom, based on the rope model. We have a rope, and the torsion of that rope is going to be light, and the two threads that form that rope are going to turn into the electron and the proton. That's the proposal. And not everybody even agrees on that. But, that's the proposal. And so now it allows you to think in different ways, especially with respect to gravity. Now we can understand, or we can make sense of action at a distance. Why does this atom affect that one? Because they're interconnected. They're connected by a rope, an elongated mediator. And that part, lots of people like, because finally we can make sense of how this ball over here affects that ball over there. That part's in general accepted. But when we get down to the nitty-gritty, what does an atom look like? What does a neutron look like? Now we run into a little bit of problems, because again, everybody said, well, the way I imagine it is different than you. And yes, they have all these different proposals. Okay, so what are some of the proposals that have been pitched in the last couple days? And I'm going to go first with a simian. His name is Monkey. And first I'm going to show him what he proposes as far as what it looks like, and then I'm going to justify it with a description. And I'm going to give a description, then I'm going to justify that description with why he thinks that way, okay? So here goes Monk's version of the neutron. And please, you're not supposed to laugh at the simplicity, because you're not supposed to look at these things as the exact copy of what's out there. The idea is to get the notion of what he's trying to do here, how he's trying to imagine the neutron. The neutron's the guy in the center there, okay? And he visualizes like cross section of ropes. Okay. And okay, so that's his version. Cross section of ropes. That's pretty much the way I look at it. In fact, maybe I should start by showing my version first so that you have something to compare it against. Here's my neutron. Okay. A little more sophisticated. That's what I put up there, and that's what everybody addressed. I hope you can see that big enough. Maybe I can go step by step. Let me make it a little bigger so we can see step by step. Here we have the atom, okay? And on the outside, what you're going to see are the ropes coming into that first circle. Again, this is a cross section, so we're looking at two-dimensional cross section of the atom. The ropes come from the outside. They meet at that circle, which is going to be the electron shell, or the electron balloon. And inside, you see that little blue dot, which really is like, if you look at it up closely, let's see if I can make it bigger. It's a it's a whole bunch of threads meeting in the center of the atom. Okay, that's what we're looking at there. And what happens, the rope forks out at the boundary of the atom, which is the electron shell. One thread goes around and the other one goes straight. And that is essentially the atom. So what is the neutron using the same model? Well, the neutron is what you see next to it here. Let's see if we can see it in a little more detail here. The neutron is a bunch of convergence of a bunch of ropes. So whereas the proton, the center of the atom, is a convergence of one thread, the neutron is a convergence of ropes. And you might ask, well, where did we get that? Well, I get it from a couple places. First, if all the atoms in the universe are interconnected, as you can see there on the right, all these ropes must converge somewhere in space. In fact, we should have convergences everywhere. Many convergences of ropes around the universe. And those convergences are what we're going to call the neutron. And the convergence there in the neutron there is what we're saying, it's going to be just approximately the size of the H atom. That's going to be the diameter of that neutron. And and that's one reason. Let's go with the second one. Let's see if I can show it here. Here we have the proton and the neutron, one next to each other, okay? And you say, well, why does the proton and the electron, in other words, the atom, why does it have charge? And why doesn't the neutron, which comes from neutral, it's a neutral particle, it does not have charge, you know, and, you know, that's the difference between the proton has charge, the atom has charge, because the electron shell is pumping, it's coming back and forth, doing its quantum jump. It's falling in and falling out. It's compressing and expanding. And a neutron doesn't have that same shell around it. So the neutron's just a convergence of ropes, and there's nothing happening other than it's just there. And I think I show it here again. Here you see, hopefully that's big enough for you to see. There's a red circle, and that red circle is where in the regular atom, the hydrogen atom, you would see the electron shell. And the neutron doesn't have that. The neutron only has a convergence of ropes. And so there is no charge because there is no that pumping action that we see with the atom. And here I'll show it one more time. Okay, the electron will be falling towards the electron shell. The electron balloon is going to be falling towards the proton and then expanding. It's going to contract, expand, contract, expand. The atom is a little heart that is pumping torsion waves to every atom in the universe. And yeah, under this model, the neutron would be like this. And what we're seeing there is, again, a convergence of ropes at the diameter of where the electron shell would be. That's where the neutron ends. That's maybe where the people in the labs measure up to that point. They say, oh, the neutron weighs more or less so much, and it has so much mass or whatever. And that neutron has approximately the same mass as the hydrogen atom. So that's where I got it from. That's my justification for it, okay? Let's see if I can make it smaller again. Okay. Okay, that's my neutron, according to the model. And here we have another aspect of it that I like. I usually like to share this together so that there is a little more information also from where I got all this. I mean, it's not like I came up one night and said, oh, I think this is the way it is. No, I got this from the literature. The literature says something. I'm trying to explain what they observed in the lab. And that's another issue we have to keep in mind at all times, that perhaps, just perhaps, they didn't see what they thought they saw. Maybe they measured what they didn't measure. And that's one possibility, that there is something wrong in what they did, and that maybe I'm just spinning my wheels because I'm basing my take on the neutron based on, you know, what they've done in the lab. They tell me something, I listen, and how would I explain that? And if they did, in fact, observe some of these things, by observe I mean they measured, or they were able to infer that this is what is happening there in this invisible world, how would I explain it? And I do have explanations. That's what these justifications are. They are justifications for why the neutron has this configuration, this physical configuration. Okay, so here's one of the things that I like to show, and that's that here you have the proton on the left and the neutron on the right. And here you can see the proton is that blue, light blue stuff in the center. The red shell going around is going to be the electron, and you can see it better now. Those are the ropes coming into the atom. They fork out at the electron shell. The red, and again, this is just arbitrary. I use the red to show the magnetic thread that goes around, and the blue thread goes straight to the center and forms the proton. And you can see on the right, you won't see the electron shell. What you'll see is simply a convergence of ropes, whereas the proton's convergence of threads. Here we have convergence of ropes. And since it doesn't have that pumping action where the electron pumps back and forth, the electron shell shrinks and expands, then the neutron is neutral. It doesn't create what is called charge. Charge is what happens at the boundary of the electron shell, the red shell on the left. And that's that little tiny friction when the electron shell expands and contracts doing quantum jump. That's what we call charge. Okay, and you won't see it on the proton, on the neutron on the right, because there is no such boundary. There's no such electron shell. All the ropes simply go through all the way to the other side. But what is the problem? The problem is that the proton and the electron on the left, every 15 minutes, and this is what I get from the literature, okay? So don't quote me on this, quote the literature on this. The literature says that a free neutron out in space, one that does not belong to an atom, one which is not inside an atom, right? That free neutron can convert to an atom, H atom, like on the left, and the H atom every 15 minutes can convert, or does convert, into a free neutron. Always talking about hydrogen atom only. So we're saying that an atom can convert to a neutron and does convert into a neutron, and the neutron does convert into an atom, an H atom. And we're talking about free neutrons only, okay? Now that's the official version. And I didn't bring it here today. I should have done that maybe. But I show in the book how one converts into the other. And they do so simply by unrolling one of the threads from the center of the neutron. It unrolls backwards and forms the electron shell, and then that same electron can do it in reverse. It can re-roll its way or wind up all the way to the center and convert itself into an atom. So it can go back and forth. It can unwind and rewind from the center out and from the outer edge of where the electron shell is inwards. And that's what I think is happening when there is a atom to neutron conversion and neutron to atom conversion. All this is based, again, on the literature. These people say this is what we observed in the lab, okay? Okay, so that's the story for neutron to atom conversion and vice versa. And the other thing I'd like to show, which also gives me an idea that, or justifies where I got a lot of this stuff, here it is. And this is how a hydrogen atom, regular hydrogen atom that has no neutrons in it, suddenly expands and incorporates, where's the, I think, oh yeah, there it is. In the first picture, you see that the atom, that's the H atom, and it's got a little neutron, that pinkish violet, purple, whatever the picture you see there, that pinkish one, little star that's next to it, that's a neutron. And the atom is going to expand, the electron shell is going to expand, and it's going to incorporate that little neutron in it, and now it's going to convert into deuterium. Deuterium is a hydrogen atom that has a neutron in it, in its nucleus. So whereas the ordinary atom only has a proton in its center and the electron shell, under the rope model, right? The deuterium would have proton in its center, and because the electron shell expanded, it now incorporates a neutron that happens to be in the region. Or that, again, it's bombarded in there. I'm sure that the sun must be creating a lot of deuteriums in there, you know, a lot of deuterium atoms, isotopes of hydrogen, because it just squashes a neutron in there. And from there we work our way to the next step, which is another neutron appears in the vicinity, and that's also compressed in there, as you see in the final picture there on the bottom left. And now deuterium has converted into tritium. Tritium is one proton, two neutrons. It's a heavy hydrogen. And just by the way, they use deuterium, the proton and neutron, for the H bomb. Okay, that's what they use. They don't use regular hydrogen. And that whole process is also reversible. In other words, a tritium atom, which is a hydrogen with two neutrons, can convert it into deuterium, hydrogen with one neutron, which can convert back to a regular hydrogen, which is a hydrogen without any neutron, or you can say that the nucleus only has a proton. Tritium is radioactive. And this more or less explains why. It says, look, the atom, the electron shell, has expanded so much. I mean, we're talking about a very tiny thing, but even so, you put two neutrons in there, it's pushing the electron shell outwards, and it just wants to get rid of a neutron because the pressure is so high in there. And so I think that's why tritium is radioactive. It just wants to get rid of a neutron because the electron shell has expanded so much. And so tritium is very unstable and it's radioactive. That's what unstable means, essentially, that it releases stuff. In this case, it releases a neutron. And deuterium, to some degree, is also, not radioactive, but it wants to get rid of that extra neutron. It doesn't like it. And finally, I want to say one more thing, and that's that, the official story is that God created neutrons so that the quantum atom could keep positive charges such as protons in the nucleus separate. It serves as a barrier because it's neutral. Okay, so if you have, I don't know, an atom like calcium, which is atomic number 20, that means it's got 20 protons, 20 electrons. This atom also has approximately 20 neutrons as an average. Remember, neutrons vary. You can have more neutrons than protons. And the official story is that the neutrons are there to keep the protons from fighting. Protons are positive and positive all over the place, and neutron kind of serves as a barrier because otherwise, I guess the nucleus would explode. And this kind of defeats, the deuterium and tritium both defeat that argument because here you only have one proton. So why did God put one neutron in the case of deuterium, two neutrons in the case of tritium inside these atoms? What is it separating the proton from? What is it isolating it from? And obviously, if with that argument you can say, well, the purpose of the neutron is not to keep charges, positive charges, separately so that they don't affect each other. No, that's not the purpose of the neutron. The neutron simply is caught in a greater expansion of the electron shell. I think that's the purpose. That's why God created the neutron. It just gets caught into a bigger and expanded electron shell. Okay, so that ends my part. And now let me work here with what other people have suggested. Here we have Monk's picture, again. That's what it looks like. His neutron is also across a convergence of ropes. Okay. How does he justify it, or what's his description of that? Here's the description. He says, let's see if I can expand it so I can read it. Give me a second here. Okay, he says, here is a summary of my position. Neutron is a composite object, okay? The neutron is to rope what matter is to H atoms. I'm not sure I understood that completely. I guess the monk will have to clarify that for us. Ropes combine to form free neutrons and are also incorporated into atoms to form higher elements. That's essentially, we agree on that. Therefore, the neutron is a linchpin, okay? What does he mean by that? A thing vital to the organization of matter. In other words, I think he's going to use it as a mediator between atoms, so to speak. I think that's what he's referring to. And it's also a pin which is inserted between fundamental and other composite objects to keep them in position. Okay? That's his justification, description of what he just drew there. An example, a neutron is held and holds together two hydrogen atoms to form helium. Keep in mind, if the monk is correct there, what is he referring to? He's saying that you need 4 hydrogen atoms to form helium, okay? And again, please let me know if there's some problem with the sound as soon as possible. You need 4 hydrogen atoms to form helium. Apparently, this is my take on it, the sun squashes 4 hydrogen atoms in its center and it creates helium. How? By putting 2 protons and 2 neutrons. And that's why you need 4 hydrogen atoms, okay? And there's a release of so-called energy, which is under the rope model is simply links in a rope that are being expelled at high frequency, and those arrive to our eyes as heat, the conversion of hydrogen into helium, creates the heat. So in this sense, we agree in how the sun works with quantum mechanics. They use fancy words such as energy, which nobody understands, nobody has ever defined. I'm saying no, let's do it with objects. I'm saying what's happening here, you take 4 hydrogen atoms, you squash them together, you create 4 items in the center of the helium atom, 2 protons and 2 neutrons with that, okay? And in that process of squashing them together, we release links of rope. In other words, we release the slack, right? It's not like we're creating rope. It's the same rope. It's just now has more slack, and that slack goes off as high frequency. Okay, so that's my take on it. And Monk apparently seems to agree with that. He likes that part. He'll correct me if not. And then, okay, so what is his justification? He says, assumption, the same amount of thread is always present. Totally in agreement. We do not create matter from space or vice versa. We do not convert matter into space. So, we can't create nothing from something, and we cannot create something from nothing. That's essentially what he's saying here. The amount of thread in the universe is always the same. So if we could measure the thread, it's a closed loop thread. There's only one thread in the universe. If we could measure the thread using meters, go around and just measure how long this thread is all around, which would be all the matter in the universe. We say, okay, it's 1 trillion miles or 1 trillion meters, whatever. It doesn't matter. So we'll call it 1 trillion meters. Then what we're saying is that 1 trillion meters is always constant. Okay? You can have maybe more neutrons than atoms, or more atoms than neutrons if they're converting one into the other. And not everybody agrees with that, but I'm just proposing this. I'm saying that you can have, at any point in time, you may not be able to know, if you froze the universe, how many atoms are in the universe, because you can't freeze the universe. They're kind of converting one into the other in between. And so maybe today we have more neutrons than protons, than atoms, and tomorrow it's the other way around, for all we know. But the point here is that the amount of thread in the universe that comprises all of matter, that amount of thread is constant, okay? Because that follows from the fact that a single thread comprises everything, every atom, every neutron out there, okay? So all this is made out of the same thread. One thread that converts into all these tiny objects. And he continues, the ratio of atoms to ropes would necessarily be changed if atoms converted to ropes or ropes converted to atoms. And he goes on to justify that. And again, that's essentially what he is saying is we cannot create matter from the void. Third paragraph, instead we may say that in the case of neutrons becoming atoms and atoms becoming neutrons, we have atoms incorporating or releasing ropes in between atoms. An atom may well slide along its rope where it encounters a neutron. Okay? So he's saying, how does a neutron get incorporated into an atom? Well, the atom slides and kind of bumps into the neutron. The neutron is suddenly incorporated into that. And the last paragraph there, I think that's what he's saying, by the way. Please, I'm trying to interpret what he's saying, so I could make an error in interpretation. Last paragraph, a neutron is a result of crisscrossing ropes. When enough are crossed, an atom may appear to be formed. An atom is not actually being formed in the sense of being created from nothing, right? An atom has slid to the point where the ropes crisscross and picks up the ropes, incorporating them into itself, okay? So he's saying again that, I guess this is what he's saying. He's saying that an atom slides along a rope. As you know, as it eats rope in front, it releases rope behind it. Kind of like, bead sliding along the abacus, the wire of an abacus. The bead doesn't pull the wire with it, and doesn't swallow, I guess. It does swallow the wire in front of it, in a sense that it goes through it, But the point is that, you know, as it eats wire in front, it releases wire in the back. Okay, so the bead that slides on an abacus doesn't stay with the same piece of wire at all times. And that's essentially the analogy for what's happening to the atom. The atom slides along a rope, and as it does so, it releases rope behind it. So an atom is kind of a dynamic entity in that sense. It eats new thread and releases thread as it moves along a given rope, okay, whichever direction it moves. And so up to that point, I think we have no disagreement with Monk. I think, okay, he's going to correct me if I said something I wasn't supposed to. Okay, okay, we have here Tom's neutron. I'll start with a picture also, and what he did was correct my version of the atom. And here I'm going to need some help because I did not understand everything that he proposed. Let's go with the first one here. And essentially, he corrected everything on the left, okay, where you see that white line all around there. So the rest is the same, or at least he didn't address it. But here we see his atom. He says the atom is different than the one I'm proposing. Okay, and he's essentially saying that the rope, I guess, swings around. I'm assuming he's referring to the rope, the blue and red threads on the bottom. Let's see if I can raise this a little bit. He calls it mating. And I am assuming that the rope is swinging around. I'm not sure exactly everything he's referring to there. I need for him to clarify that to me. And here he shows a picture of what he considers the proton to be. Again, he uses the term mating. They mate. Maybe Tom had sex in mind. I don't know. Maybe he is sex starved, and that's where he got the idea. Hopefully, it's a positive origin for his thoughts. And he says ropes from different locations. Okay. Okay, that's how he pictures it. Here is his justification for it. First, the description, then we'll go with the justification. He says, I don't agree with it completely, referring to my picture. Oh, I'm sorry, Tom. I thought it was, Tom says this is Martin Yarhult's illustration. Okay, so I'm mixed up a couple guys there. I thought it was Tom, it's Martin instead. Okay, fine. No problem. Again, the point I'm trying to make that people were brainstorming different ideas, and okay, so we'll take that. This is Martin's. As I said, he says, I don't agree with it completely. I've therefore revised. Okay, no problem. Okay, I've therefore revised your atom chart. Okay, my revision stems from the idea of mating ropes forming the atom, not convergence of threads. Okay, so he's saying that this mating of ropes is what forms the atom. I still don't understand it completely, and I'm just going to have to ask him to clarify that maybe tomorrow or in our forum over there in Facebook, exactly what he's referring to with mating of ropes. The monkey also had some questions about that, so we're not understanding exactly what he means by mating of ropes. And please don't be shy. Don't feel that you're going to be embarrassed or anything like that. It doesn't matter. We're brainstorming and we're dealing with something we can't see. So all ideas, as crazy as they might be, are welcome. Okay, everything goes here. Just come with your best idea, even if you don't match Mother Nature's idea or what she really does out there. It doesn't matter. We need all the ideas we can get. And he says, with mating of ropes, we have a physical structure holding the shape of the atom fixed. I find that fixed shape impossible with converging threads. I think what he's saying, I'll try to put words in his mouth again. He's saying that he doesn't like the idea of, I guess, the two threads forking out at the electron shell and one thread continuing to the center of the atom, and the proton in that case being made of a single thread, you know, a bunch of convergence of threads. Instead, he says the atom is a convergence of ropes. I think that's what he's saying. I cannot imagine that because then we have to distinguish that from the neutron, and I'm not sure exactly how he does that yet. Okay? And a few things make me feel that neutrons are really just hydrogen atoms that do something. Okay? Fine. Neutrons are neutral. They are neutral typically because they don't do something, but not doing something is also doing something. So I have no problem with that statement. And what are the things that they do? They have the same mass, okay? Essentially, they do. A proton and an electron together approximately have the same mass as a neutron. That's what we receive from the lab. And again, I would urge you not to put your life on the line for that, okay? And that's important. We can only use whatever these people tell us that they've observed in the lab. We don't deal at this level on a daily basis. We can only try to theorize, explain what these people say that they saw in the lab or what they experienced, what they measured, whatever. And they're saying that they approximately have the same mass. The neutron equal to approximately the mass of a hydrogen atom. And we're talking again the most popular hydrogen atom. We're not talking about deuterium or tritium. No third thing comes close to their mass. Okay, fine. Next in line is deuterium with mass 2. Okay, fine. Neutrons magically reappear. Yes, and I assume he's referring to the conversion. Oh yeah, I think that's what comes next, number 4. They convert into each other. Hydrogen to neutron, neutron to hydrogen. And again, this is what we get from the literature. Don't put your life on the line for it, but it's a good speculation or a good assumption that maybe what they saw in the lab is correct. Okay, that maybe it matches what Mother Nature does out there. So, you know, just treat it with lightly. That's all I'm saying. Okay. Okay, what is Martin's justification for it? He says it takes 4 hydrogen fused together to get 1 helium, and I agree there. 2 of which convert into neutrons, okay? Yet the mass stays the same, yes, and maybe sometimes they disappear, but they are permanently fused together until fission or decay. Okay, well, no problem there, at least from my point of view. What's the likelihood that 2 things exist that are almost the same? Martin says 2 first paragraph. Yeah, this is... Oh, okay, I got them mixed up. Please don't beat me up. I kind of did it. I copied some of the things that I saw in the Facebook forum, so I could have confused both you guys. Don't kill each other and don't kill me. Okay, you probably know what you put out there. Okay, so correct me whatever when I use your names. I'll try not to use your names. I'll keep you anonymous. Okay, so what's the likelihood of 2 things that are almost the same, yet one is permanent, the other is temporary, okay? So one of the 2 says, so why can't we explain neutrons as simply being squeezed or collapsed hydrogen balloons? And I don't know if this was also from Monkey. Maybe I'm using his words here, okay? The collapse of the electron shells create what we call a neutron. Okay, and the electron collapse means it will have no charge and emit no light. That's the model that I'm proposing, okay? So if one of you 2 guys propose that, well, we're on the same page, okay, as far as that's concerned. Okay, and now I've got someone else. Maybe this is Tom or Martin. I hope I don't confuse you. Oh, no, this is Dan. I think it's Dan. Let's go with Dan's. And Dan says the following. He drew this, which I liked. Not that I agree, but I liked. I liked his 2 pictures, especially the second one I'm going to show in a minute. And he tried, I guess he's trying to show here what I'm proposing, at least as far as, you know, the first 2 pictures up on the top. That's my idea, where I'm saying, you know, the rope reaches all the way to the electron shell. There it forks out. And one turns into the proton, which is the blue that's in the center. Okay, so far so good. We're in agreement there. And then the one on the right, up on the top right, okay, is the neutron. It's just the ropes going through a center, okay? The only thing I would object to is that, you see a little curvature there. I want to make sure that those ropes are straight, okay? Because the rope coming from one atom over there in the middle of nowhere goes right through the center and continues going to the middle of nowhere in the other direction. In other words, all these ropes just crisscross and they're tight. So the neutron is a perfect star in that sense, a perfect ball. Okay, it's just, and that's up to the radius of the atom. If you take that little chunk of ball there, if you could cut the ropes at the diameter of the electron shell, you would have a neutron ball. And what is the neutron ball? Well, it's a porcupine that's rolled over a sea urchin with all the quills pointing in every direction. That's essentially the image that you should have in your mind. Okay, so now the next one, that's on the left-hand side, second picture down, the one in the middle. He's opening, I guess he's going to open that, right? He's saying that the threads from the neutron start pulling outwards, as you can see there, and it leaves the proton in the center. And that thread, and we'll say that the red thread is pulling out, is unrolling itself. That's going to create the electron shell, the red circle that you see encapsulating the proton dandelion, as I call it, because that's a good analogy for that as well. And the one on the left and the bottom, we go from atom to neutron, the same thing but in reverse. And the third one, the last one, the third one on the right, I guess, is just a, it has both in there. And I'm not sure if he's saying that, I think this is what he's saying, but again, don't quote me. Maybe this is what what an atom that is higher than hydrogen, could be deuterium there, I guess, that's what he's showing there, where both the proton and the neutron superimpose upon each other. And again, I don't want to double guess them, but this seems to me, okay, that's what he's showing there. He's showing how if you want to build deuterium, you're going to bombard that center with a neutron, and it's going to superimpose with a proton. And so the single line there that you see, that's going to be the proton dandelion, all the quills pointing every direction. And the neutron superimposed on that are all these ropes that crisscross there as well. Okay, so I love that picture. It's pretty good. At least it conveys the idea. That's the image I have in my mind. I don't have to put them side by side the way they're always drawn by quantum people. They put proton next to the neutron, and here he's putting them together, which is good. That's new. I didn't think of it that way either, but I think it's a very good proposal. And let me go with his second picture, which I absolutely loved. I'm going to see if I can steal it from Dan. Maybe he'll allow me to steal it. And that's what he did here. He's showing a cross section of an atom. In this case, it's the tritium atom, I guess. And he shows two neutrons superimposed on a proton, I guess, proton dandelion. That's, I think, what he's showing as you work your way down. Okay? And that's as I understood these pictures. Loved them. Thank you, Dan, if you're still there. I think this is very good. This is good work. At least to convey, doesn't have to be perfect. It's just that you need to convey the idea. You need to communicate the idea that you have in your mind, and this is good. This is good for that. It could be that the atoms, especially at the hydrogen level, the protons and the neutrons superimpose. The question is whether higher elements, more massive elements, such as, again, calcium or carbon or oxygen, whether they, because remember, they have p orbitals. They have all these balloons sticking out, like, you know, a clown that does all these tricks with balloons and puts one balloon next to the other, and you have all these balloons sticking out. Well, you have a round one in the center, and then you have all these p orbitals, figure 8 orbitals, right, sticking out of it in every direction. And the question is whether the neutrons are all in the center, in which case they are not captured neutrons like Monk and I suggest, I guess. Captured in the sense that they would form the nucleus of the p orbital. It's like they all go to the center. So you have superimposed protons and neutrons all in the center, okay? And the crisscrossing of ropes and the crisscrossing of threads in the center. But then you'll also have the p orbitals, which are just the round balloons. And all the protons are in the center somehow. And that's a new idea too, for me at least. And I think that's what Dan is proposing. He'll correct me if I say something that I'm not supposed to. But I like his pictures. I thought that was pretty good. And here's, I think he had a justification for that, or no, there was a tiny debate there, and we didn't get an answer to that, but Monk said the following. He said, ropes don't bend. And I agree with that statement, and let me tell you why. Rope is pulled tight. It has to, in order to send light, electromagnetic waves, torsions. So in order for the rope to carry out in a straight line, you know, to be straight, and at the same time be able to torque light in a rectilinear path, it cannot bend. And when I did my work and looked at all this, I could not discover any situation as of today in which the rope can bend. It's always tight, and part of it is because one is wound around the other. They're pulled tight, so they embrace an axis. So in a sense, the thread is already curved, but the rope, if you look at the rope, you could say it's a straight line. But of course, a rope is never straight in the sense that architecturally, you know, it's not straight. It's already a bent object in that sense. All we're saying when we use the word straight is that the two threads embrace an imaginary straight axis. That's all we're saying, okay? So keep that in mind. Rope pass-through rope, what would keep that neutron within the... What would keep the neutron within the electron shell? Rope pass-through rope. Well, yeah, but see, keep in mind, Martin. Okay, so I see what you're saying. But you need to explain mating a little more clearly. I'm still not understanding exactly what you mean by mating. But let's see if I can make sense of your previous statement. Ropes go through ropes under certain circumstances. Keep that in mind. Only under certain circumstances. What would keep... There's a problem with sound again? Oh, Jesus Christ. You know, it always starts at the same time, towards the end. Okay, let's see. Okay, let's see. I'm not sure what happened. Okay, we'll have to cut today, and we'll continue tomorrow. I'm not sure why I'm having these problems. I'll see you tomorrow, same time, same station. Bye-bye.